Have you ever sat by the window of an airplane, waiting to take off, and wondered about the incredible power just outside? What exactly happens to get this massive machine from a standstill at the gate to soaring tens of thousands of feet in the air? Today, we're going on an engineering journey, deep inside the heart of a modern jetliner. Its powerful engines will demystify the entire process. From the quiet hum at the gate, to the thunderous roar of takeoff, imagine it's a calm morning. The sun is just starting to peek over the horizon, casting a warm glow on the airport. Our aircraft, a state-of-the-art wide-body jet, is parked peacefully at the gate. Everything is still. Inside the cockpit, the pilots are going through their pre-flight checks. They're like conductors of a complex orchestra, and the performance is about to begin. With a series of precise movements, they flip switches, each one sending a signal, waking up the plane's various systems. Power flows, screens light up, and the aircraft comes to life. Now, the moment of truth for the engines. The start sequence is initiated. It doesn't begin with a sudden explosion, but with a subtle, almost whisper-quiet process. A smaller auxiliary power unit, or a PU, located in the tail of the plane, provides the initial burst of compressed air needed to get things moving. This air is ducted to the first engine. Think of it like giving a gentle push to a giant, heavy pinwheel. Inside the engine, this initial push starts to spin the massive fan blades you can see from the outside. As these blades begin to turn, they draw in a huge volume of air. This is the first stage of what's called a turbofan engine. A portion of this air, called the bypass air, goes around the core of the engine. It's simply accelerated and pushed out the back, generating a significant amount of thrust quietly and efficiently. This is why modern engines are so much less noisy than their older counterparts. But the real magic is happening inside the engine's core. The rest of the air is funneled into the core, where it enters a series of compressor stages. Each stage consists of rotating blades and stationary vanes that squeeze the air, dramatically increasing its pressure and temperature. It's like pumping up a bicycle tire, but on a colossal scale. By the time this air leaves the compressor, it's incredibly dense and hot. This super compressed air is the key ingredient for the next step, combustion. Now, we move into the combustion chamber. This is where the power is truly unleashed. A fine mist of jet fuel is sprayed into the chamber, mixing with the hot, compressed air. An igniter, much like a spark plug in a car, provides the initial spark. The result is a continuous, controlled explosion. This isn't a single bang, but a sustained burn, a self-perpetuating flame that raises the temperature inside the chamber to over 1,000 degrees Celsius. This intense heat causes the gases to expand violently. These superheated, high-pressured gases have only one way to go, out the back. But on their way, they encounter the turbine. The turbine is a series of bladed wheels, very similar in appearance to the compressor. As the hot gases blast through them, they spin the turbine blades at incredible speeds. This is the brilliant part of the design. The turbine is connected by a central shaft back to the compressor and the main fan at the front of the engine. So, the energy from the burning fuel is used to spin the turbine, which in turn drives the compressor and the fan, which pulls in more air to keep the whole cycle going. It's a beautifully self-sustaining loop of power. Back in the cockpit, the pilots are monitoring everything closely. The engine displays show that the RPMs, the revolutions per minute, are stable. Temperatures and pressures are all within the green, indicating a healthy, smooth start. The first engine is now running on its own power, emitting a low, steady hum. The process is then repeated for the second engine, and soon, both are idling, ready for the next phase. The ground crew disconnects the jet bridge and ground power, and with a signal to the pilots, we are cleared to push back from the gate. A tow tractor gently pushes the aircraft backward onto the taxiway. Once clear, the pilots get clearance from air traffic control to taxi to the runway. They release the parking brake and advance the throttles just a little. The low hum of the engines deepens slightly as they provide just enough thrust to get the multi-ton aircraft rolling forward. Taxiing is a slow and deliberate process. Following the yellow lines on the pavement, a giant gracefully navigating its way through the airport maze. As we approach the runway, the pilots perform their final checks. Flaps are extended, control surfaces are tested, and everything is confirmed for takeoff. We get our clearance cleared for takeoff. The aircraft lines up on the runway center line. This is it, the moment of maximum power. The pilots advance the throttle levers all the way forward. Instantly, the deep hum transforms into a deafening, awe-inspiring roar. Fuel floods into the combustion chambers, and the engines spool up to maximum power. The sheer force is incredible. You're pushed back into your seat as the aircraft accelerates with astonishing speed. Look out the window and you can see the heat shimmering in the air behind the engines. A visible distortion caused by the sheer velocity and temperature of the exhaust gases. The bypass air and the core exhaust combine to create a monumental jet of force, propelling the aircraft down the runway faster and faster. The numbers on the cockpit displays are climbing rapidly. Airspeed is increasing. 80 knots, 100 knots, V1, VR. At the rotate call, the pilot gently pulls back on the control column. The nose of the aircraft lifts gracefully towards the sky. A moment later, you feel a slight bump, and then smoothness. The rumbling of the wheels on the tarmac is gone. We're airborne. The wheels retract into the fuselage, cleaning up the aircraft's aerodynamics. The engines are still at full power, driving us upward at a steep angle, gaining altitude rapidly. The world below gets smaller and smaller. We climb through the initial layers of atmosphere, and soon, we break through the clouds into a brilliant, sunlit sky. Up here, the engines are throttled back to a more fuel-efficient cruise setting. The powerful roar softens to a steady, reassuring drone that will be our companion for the rest of the journey. The incredible sequence of engineering marvels from a single spark to a continuous, controlled burn, from spinning blades to immense thrust, has successfully lifted us from the ground and set us on our way across the sky. It's a testament to a century of innovation, a symphony of physics and engineering working in perfect harmony. Thanks for joining this deep dive into the heart of a jet engine. If you enjoyed this journey, be sure to hit that like button and subscribe for more explorations into the incredible technology that shapes our world. Fly safe, and see you in the next one.